Welcome everyone to another CTC Software webinar. My name is Sean Zervis, the Director of BIM Development here at CTC Software. And in today's session, I'm excited to continue along with you on this CTC Analytics Learning Series. We're technically in part, I think, 7, but we're in a little sub-part here, a little sub-breakout series, part 3 of the Web API data storage portion of this Analytics Learning Series. Today, we're continuing talking about Python and using Python to store data in a SQL Server somehow. We're going to take a look at that throughout the discussion today. Now, as always, of course, these webinars are recorded. In this way, you can come back to this webinar in the future when you start to leverage these techniques for yourself. Also, as always, for those of you who are participating with us live in the webinar while it's being recorded, we encourage you to ask questions in the main GoToWebinar questions window. I try to keep my eye on that window, and I try to answer questions while I'm going through the presentation if it fits well into what we're already talking about, so you can get your questions answered right away if you're here with us live. Also, for those of you watching this as a recording, we hope to earn your likes and subscribes. We hope that this will be a meaningful workflow and process for you as you're going through and learning Python, learning data storage, and certainly interacting with your data that comes out of CTC software. So without further ado, let's jump in and talk about today's topic. As I've said before, in our modern culture, data really is the king. If you have information and you can work with that information, understand it, navigate it, it really does help you to make much better data-driven decisions. And that can really affect a lot of things. It can affect your profitability, your spending efforts, your training, your knowledge of a lot of portions of your business. So in part 2, last session, we talked a lot about what we're going to call strongly typed data structures. Taking data from the API, pulling it into a data set. And in that session, we talked about writing that information to a JSON file or a series of JSON files. And that helped us lay a foundation for this ongoing conversation of data storage. So you can fetch data and then over time build up your data so you're not getting just 30-day chunks and that's all you have. Way earlier in this series, we talked about using Excel and Power BI. The problem with Excel and Power BI is they can only store a finite amount of information. They're not really good databases, and they don't have the logic in Power Query to really fetch new data only. It only understands how to replace all of the data. And so in this portion, we're kind of shifting gears here and talking now about how we can store this data in a much more efficient way. Today in this part, we're going to talk about storing our data in a SQL Server system. We're going to talk a little bit about setting up SQL Server and talk about some flexibility that we've got there and how you can integrate this much more with internal systems when it's in some kind of a SQL data structure. See, JSON files are great, but they are not the best storage methodology. There's better ways of storing data. SQL is one of the best, I think, for this kind of data, and we're going to talk a bit more about why that is today. So we're going to go over a few things. We're going to talk about database structure and why it matters and what we're doing here with this little portion and why we're doing this inside of SQL instead of JSON, strictly JSON. We're going to create the database structure using code, so we don't have to do this manually, because manual database creation, I was just having a conversation with a coworker about this, manual database creation and manual table creation is slow, it's tedious, and while it can be done correct, it just takes a lot of time. So what we're going to do here is do this in a much more automagical way, using code to do it all for us. Now, we're also going to write some data to the database. It's going to pass through the API. It's going to grab the JSON information. It's going to convert it using our strongly typed data sets, and then it's going to dump that information into the database. And this is going to set us up for some really good long-term data storage and data retrieval to actually use the information. Now, while that's writing, of course, we want to verify that our information is properly written. And we're going to take a look at a couple of simple queries that you can use to actually ask the database to give you back the data that's been stored. See, with a JSON file that we did last time in the last session, you're able to just open the JSON file. You can see a lot of information, but it's not very usable in that format, and there's a whole bunch of JSON files. Today, we're going to put it into a single database that has all this information related together, and we're going to verify that that information is written correctly, again, using some simple queries. So let's quickly rehash where we are in this series roadmap so you know where we are. We've got all 8 of these topics, and we've covered all of these topics in gray already. Today, we're in the second to last session here. We're talking about using Python to store data in a SQL database. Now, if you have any questions about the previous sessions, they're already up on our YouTube channel. We encourage you to go review those. We think they're going to be really valuable for you as you're going through this exercise of working with data out of the CTC reporting API. Now, we've talked about this a little before, but I'm going to talk about it again in this session just in case you've missed some of the previous ones. To be able to do any of this, there are a few prerequisites that you have to have in place. First, for today's session especially, you have to have an API key from CTC. Doesn't cost you anything. If you're a CTC customer already, we're more than happy to get you an API key so you can start accessing your cloud data. You can ask for this API key from license request at ctcsoftware.com. They'll get that key sent over. You can use it pretty much immediately because they're probably going to be able to do it in a matter of seconds for you if you ask for it right now. You also want to make sure you get the data set that I'm using from GitHub. I've already written all the code we're going to talk about today. I'm going to introduce you to certain portions of it that are new from our last session. But if you just get this code, you should be able to pretty much, with few modifications, run it today and be able to follow right along. Now, you can get this code from github.com/SeanZsCode/CTC reporting API. That little collection right there, all the code, and I will be continuing to keep that up to date as more improvements are made. So I recommend that you use GitHub Desktop. Go get yourself a GitHub account, go download GitHub Desktop, connect to this repository, fetch the main branch of that repository, and you will have all of the code on your system exactly as I have it on my system, and it should work for you exactly as it works for me today. You will need to have Python version 11 or newer installed. And I recommend beyond that that you also install Visual Studio Code. That's the integrated development environment, or IDE, that I'm using in today's session, and I have all the Python extensions put on there as well as a few other items as well. And then, new prerequisite for today, you're going to want to make sure you have either Microsoft SQL Server installed or PostgreSQL Server installed. One of the two. That's what I have this set up for. You can certainly integrate with a different server system if you'd like to. That's totally fine. You'll have to do a little bit more work with the Python code to do that, not much, just a little bit. But you'll want to have one of those two installed for today. Now, the nice thing about PostgreSQL is it's very, very functional, has a lot of power. It's very popular. It's also free, so there's a lot of advantages there. However, I know many of you in your offices probably already have a SQL server, a Microsoft SQL server set up. And so we do support Microsoft SQL Server with this as well. And in fact, I'll be showing a lot of Microsoft SQL Server today. If you don't own Microsoft SQL Server, that's fine too. You can use Microsoft SQL Server Express. The trick about Express is it has a 2 GB data limit, and it's limited to a single core processor, which means your data fetching and your data writing might be a little slower, and there's going to be a cap on how much data you can store. You say, well, Sean, how much data will there be? Well, I don't know. It depends on what you fetch. Honestly, it depends on how much data you go after, it depends on how much detail you want, and it depends on how big your company is. But I will give you a sort of a reference. My data set, my full downloaded data set, with all of my information from CTC Express Tools, my little fake company that I use for all my demonstrations, is about 77 megabytes in file size in SQL Server. So it's very small. The way that SQL Server structures and holds this is actually quite efficient. So it'll probably take you a long time to outgrow Microsoft SQL Server if that's the data set you want to use. All right, those are the prerequisites. Again, though, if you wanted to go free route, PostgreSQL is a great free route, and it's pretty easy to set up, and we'll talk a little bit about it today. I'll actually demonstrate both being written to today. So before we dig in too deep into the data structure or into the actual using of the code, let's get a little baseline in place. In case SQL is a little bit new to you and you're like, oh gosh, man, this is beyond what I kind of signed up for. Well, hopefully not, because in the world of data, SQL or structured query information is actually pretty common, and it's really, really powerful. So I'm going to encourage you to get a little bit of knowledge under your belt, and I'm going to give you just a little baseline, like 10,000 foot view today. So let's start at the very beginning. Data in our world always relates to something else, no matter what, right? The temperature in your room is the temperature in your room because of the temperature outside and the heaters or chillers that you've got at play. And the thermostat on the wall is trying to help maintain a set point. All of that information relates together. The thermostat's taking in what's the current temperature, should it heat or cool the space, and then depending on what gets set there, it'll do that. Now, if that data is being logged, well, it has to be in a database and understand what time the temperature changed, what it changed to, whether it fired the heater or cooling system, you know, whatever. All of that information, if it's being logged someplace, is doing that, right? Your bank account, the pluses and minuses in your bank account, that data relates to something else. There was a spend or there was a credit given to you somehow, whether it's a paycheck or whatever, that relates to other things. That database, that data set relates to other stuff. Now, if you're trying to track this information, you need to structure that data in a way that helps you better understand that information. You know, having a database or a table that talks about, you know, expenses or credits, whatever, and then your bank account relating to, hey, there was X amount sent to this particular creditor or this particular, you know, whatever, you can structure and relate that data together so you can ask it questions later. How much this last year did I pay to utilities, right? You can ask that question if you structure it in a good quality way. Now, when we're talking about asking the question, this is where the term SQL or SQL comes into play. What SQL stands for, or SQL, it stands for Structured Query Language, SQL, Structured Query Language. It means you can ask a question of a data set in a very specific way, a structured way, a consistent way, and it will give you answers back, also in a structured way. Now, to do that, to be able to ask a structured question in a structured way, you have to have your data stored in an environment where that data relates together in a structured relational database. And that's where SQL Server or PostgreSQL comes into play. Now, with this, the reason why this is going to matter for us, we're going to take a look at 6 specific tables that come from the CTC data set. And these actually come from 3 different API questions. So these 6 tables right here, you're going to see exact tables like this. This is a screenshot that I took out of SQL Server that relates to the 6 tables that this data set today is going to write for us. On the top left there, we have the users table. This is coming out of my accounts collection or the accounts scope. This accounts collection here for users has some basic user information. The user's ID, first and last name, a display name, which is first and last combined together, their email, right? All their information is structured here. On the top right corner, we have groups of users. And so there's an ID, there's a name of the group, there's a description of the group, there's some information there about who added it. That actually relates back to the users table because somebody had to be one of your users to add a group to your account. Who updated it last, so you can actually have some history on that. Again, that relates back to the users table. But then there has to be some kind of intermediary table here so we're not repeating information over and over and over again. And this is the group members table right in the middle. This group members table helps me understand what users and which groups are sort of paired together. So there's just a simple collection of group IDs, member IDs. That's what kind of relates them. Anybody in this list, if they have a certain group ID association for that member ID, they're a part of that group, right? That's a way of structuring the data. And this way I don't have to have the group called out, 85 times for 85 unique, distinct, different users. I can call the group out once and then relate its ID to another table to figure out what the pairings are, what those matchups are. In the backside, on the cloud, in the actual portal, this stuff's happening all the time. Anytime you're in any kind of environment where you sign in and then you start making changes to your account, data like this is traveling around and being structured in a database somewhere and stored somehow. Similarly, for individual users can have roles. Well, you have to have a table that knows what the roles are. So we have a roles table. And the user roles here just pairs up which user IDs are associated with which roles. Similarly, groups in our database, the group itself can have roles, and anybody who's related to that group also automatically inherits those roles because, again, relationships. So in our API, you can ask for the users and ask for the detail of what roles they're associated to. You can ask for the groups, and you can ask for what roles the groups get and which members are a part of the group. And of course, you can ask for roles. And so these three intermediary tables here, we're deriving from the data set that comes down from JSON, and we're structuring it in a way and relating it together in a way that just makes sense for the database to store it in the backend system so that we're not duplicating and replicating information all over the place. All right, so how do we generate this? How do we build this structure? So with generating database structures, of course, you can 100% build this out all by hand. You can define each table, name each field, give each field its properties. You can do that all by hand. But that is really, really kind of tedious. We've already defined in our previous sessions a data structure, a very strongly typed data structure. A username, for example, we know is going to be a string. It's going to be a series of characters. We have a general idea of how long names typically are, and we can tell the database about that. So we can piggyback on this already built up, strongly typed data set from the API core area that we've worked on before. And we can leverage that within Python to automatically build the tables and to automatically build table relationships and dependencies. All of that can be done, for the most part, automatically. And we're going to take a look at this code here in just a moment inside of Visual Studio, but let's take a real quick look at what the process is going to be. For you on your side, after you've got the code and you've got your database system set up, you're basically figuring out here which SQL Server system it is you want to target, whether it's Microsoft SQL, PostgreSQL, MySQL, you name it, whatever you want. You need to ultimately create yourself a way of accessing that database. Typically, with a more formalized server system, there's going to be some kind of username password. You need to know what that is because we're going to have to use that setting here in a moment. You also will need to create a database in which you can store your data. So I'm going to do this two different ways today. You'll see me do this here in PostgreSQL. Right here, I'm going to build a database. So I've got this. I'm using pgadmin4 actually as my manager. In fact, I think, yeah, we'll come back to that in a minute because I'm going to talk about those here in just a minute. But I'm using pgadmin4 as my admin manager. I'm going to go to my databases and create a brand new database. This database is going to be called CTC Reporting DB, and I'm going to call this webinar just for today's example. If I could spell, that would be glorious as well. There we go. Reporting. Oh, and I can't spell reporting either, apparently. CTC Reporting DB webinar. All right, I'm going to copy this just in case I screwed it up, and I'll save it. So I have a database. It's empty, but I have it, right? If I expand out schemas, there's just a public schema. That's all that's here. We're going to be adding some more to it here in a moment, but for now, it's empty. Now, I'll do exactly the same thing over here in SQL Server. This is using SQL Server Management Studio. And over here, I'm going to do the exact same thing. Database, new database, same exact name, use some default settings. You can, of course, set up much better rights if you'd like to. You can set up the path at which these databases are actually stored and where the log files go. I'm being lazy here and just letting it be where it goes. So CTC Reporting Database Webinar, okay that, and I've got a database. Once again, this database, if I expand out tables, it's empty for now. And if I go to security and I go into schemas, it has the defaults baked in, but it's basically empty for now. All right, we're going to come back to this. Now, once we have the database, we need to update Python and its settings to match the choices that we've made. I've chosen a database server. I've built a database. I already have a username and password in my environment that I can use that I'm going to piggyback on to leverage this. But we basically have to update Python settings to match our choices. And then after we do that, we're going to use the create all function from the main.py file to actually build out our database. And it's going to happen very quickly. Before we get there, though, I want to take you on a little tour of what's going on inside of here. So let's pop into Visual Studio Code. We're going to take a look at what's going on inside Visual Studio here to see what's up. Now, first off, let's take a look at our settings. The settings here, you need to target whichever server language it is you want to speak with. In my case, I've got two different major connection sets configured here. One is for Microsoft SQL, one is for PostgreSQL. If you change whatever database it is you want to go to, make sure you update that here. So I'm going to paste in the name just in case I screwed up my typing. I'll make sure it's inconsistent the same way everywhere. If you have a different username and password than I have, that's totally fine. Just make sure you put in your username and password for connecting to your database. So my Microsoft SQL server, I've got one username and password. My PostgreSQL, I have a different username and password. I've made sure I plug that in. You also want to make sure that you have your proper host set up. So what machine, what server is this on? In my case, it's just on my laptop. This totally will be hosted. It can be hosted by your own machine if you want to. The equivalent to that is just localhost. I could put in my server name, the actual name of the machine on my network, or just localhost if it's on my local system. Either way will work. Doesn't really matter. You just want to make sure now that your server language here is set up to go to the correct server, whether it's PostgreSQL or Microsoft SQL. I'm going to start with PostgreSQL for the first part, and we're going to do some steps here to make sure that this writes. Now, quick note. I noticed today in testing with a coworker with this main data set that when they pulled down the full repository, their schemas folder underneath SQL connection, the S in schemas was capitalized and the T in tables was capitalized. I don't know why GitHub did that. I'm trying to figure out how to get that fixed for future pulls of data. But if you simply right-click on that folder and you simply rename that folder, rename it, and make it a lowercase s for schemas and a lowercase t for tables, everything will work. If you don't do that, it won't work. So again, GitHub somehow cached capital letters, probably before I standardized my structure and my naming conventions to match Python PIP standards. But either way, make sure you update that to be lowercase. Python is very much a case-sensitive language. So we've modified settings. We've modified the table, the folder names here so that the data that's in here is all updated. We could, in theory, right now, just write the structure of our database. But before we do, I want to show you a little bit about what's going on with these tables. So if you expand out tables here, and for that matter, schemas, in the schemas, I have 4 distinct schemas being created. There is a core schema, an accounts, 5 distinct schemas: core, accounts, cloud shared licensing or CSL, CMS for content management system, PAL for project activity log. And the associated tables will dump into their associated schema. This helps you kind of keep your database organized a bit better and know exactly where data is coming from, which API call, which sort of major section in the API it's coming from, whether it's accounts, cloud shared licensing, CMS, or PAL. Now, if there's certain bits of this you don't care to use, you can simply delete them if you really want to. It doesn't hurt to have them made in the structure so you have it there for the future, but the possibility does exist if you wanted to change any of this. Within the tables, then, I have folders for my tables that match those schemas to help keep things organized, right? And that's important. Like the CMS collection here, fairly long, and it's going to get longer. There's a few items that I want to add to this for even more detail. So I felt it was probably made the most sense to organize this in a clean way. Accounts is actually pretty short. It has very few tables that it's actually making. If I collapse that and go into something like cloud shared licensing, again, very few tables here, but it's organized so that you can start to investigate what's going on there. If we take a look at the accounts, users, which is kind of required no matter what we're doing here. What this is letting me do is piggyback on a package, a collection of packages here called SQL Alchemy. SQL Alchemy is an object relationship manager. It's actually a database object relationship manager. And this is what's going to allow me to automatically target any database that I want to go to, any database system that I want to go to. As long as it's within SQL Alchemy, you can target it. I know it can go to PostgreSQL and Microsoft SQL, but you can also target, for example, SQLite, MySQL. There's a few others that it can go to, though there's some specific limitations in those environments that I chose not to target for myself because I like using the schemas in a database just to organize my data better. And this doesn't necessarily let me use schemas if I'm outside of the two that I'm already using. I'm less familiar with those ones. So you can feel free to modify and target that if you want to. Within here as well, we're piggybacking on the API core stuff that we talked about in our last few sessions. So in this case, we're talking about the users table, and there's a user object and a base user object. The base user object has just the core stuff you would get with no extra detail. The full user object has all of the extra detail. Oops, didn't mean to go there. All the extra objects. So here in the table, I'm actually defining what the base table looks like. So these are all the fields, and the object relational manager, the SQL Alchemy, will actually automatically build this users table in any of the databases that I want to target. And it'll automatically build the schema, if appropriate, for any database that I want to target as well. So it's going to know that this relates to accounts. It knows it's the users table. It knows that it has an ID, that it's also the primary key, and it knows all the other fields and whether those fields can be empty or not. So the database is going to further force compliance to the data structure so I know my data is good and clean. And then within each of the tables, there's typically a create new entry for that, and there is also a read the entry for that. And in the future, the update and delete features will be built in as well. But for now, it's create and read. So every one of my tables pretty much looks the same as this, except for it's custom to that particular collection. So every one of these built out tables is for that particular data that's going to go in there. So if we wanted to go to something like groups, it'll look very similar. It's going to have all the same imports inside of here, except for it's targeting group and group base, and then it's going to have the group table. Now, group roles, a little bit different. This is pulling in just the group ID and the role ID, as you saw from that little relational map, and a refreshed ID, so I know when it was last refreshed, when something may have changed. But this is the base table, and again, has a create, and it has a read function inside of here. So all of these tables, we can very quickly now build all of them with a very simple call. Down here in the main.py file, all I'm doing is I'm importing from the database main connection here. There's actually a file here called dbmain inside of the SQL environment. If I collapse all the tables, make this a little easier to read. Inside of SQL connection, there is a file inside of here that is called dbmain. dbmain talks about how to create all of the table data. So up here, there is a create all function. There is a drop all if you wanted to destroy all of the data in that database. And there is a write set of functions here to write all of the data. This is very similar to what we did in our last session where we did write or fetch all JSONs. So it knows how to fetch everything. In that case, it was writing it to files. This write all is writing all directly to the database. So I'm going to be able to call the write all, the create all, or the drop all directly from an external main function here and have it just do those steps. So we're going to start here with just create all. If I, oops, tab that. That wasn't what I meant to do. Undo. There we go. I meant to do control and slash will uncomment a line. It will remove the commenting here. And this create all function will take a look at all the settings and basically build my database. So if I hit F5 here, this right now is targeting PostgreSQL. It's going to do the connection. It's going to finish, here we go, finished in 0.01 minutes. It's actually something I forgot to do. Let's clear. Let's I forgot to set up my virtual environment here, and I should have done that. I do have some other required, what are they called, packages that are there, but I want to make sure I'm working within the confines of my virtual environment so I don't create any oddities on my main computer here. So virtual environment, scripts, and activate. There we go. Now I'm in the virtual environment. And once again here, if I do F5 to run all, it runs, it connects to the database, and it should tell me here that it finishes in a very short amount of time. Yeah, 0.01 minutes, really quick. So no issue there. Let's just clear this. Oops. Clear this again. And so if I jump into PostgreSQL over here, what I was targeting, and I refresh my schemas, notice how I have all of those new schemas? And if I was to expand out something like the accounts collection here and go into the tables, I have all of the tables that are organized under accounts. And if I was to expand out, say, the groups table, and I take a look at its columns, it's going to list out for me all of the columns that exist here. And things like the added at column, if I was to check its information, look at its properties more deeply, it would tell me, sorry, added by ID, and take a look at its properties, it would tell me that it depends upon a related value inside the users table. The relationships here have all been built up as well, okay? Now, if I wanted to target instead of PostgreSQL, and you're like, no, Sean, I don't want to target that. I want to go to SQL Server. Great. Let's take a look at this real quick. And I'm going to stick with SQL Server for the rest of today's conversation. All I have to do here is change this to Microsoft SQL, MS SQL. That's what it has to be. And if it's MS SQL, it'll look at the MS SQL connection settings here and talk to it instead. So if I just close this and rerun this again, F5 on this, that'll rerun it. Again, it goes through and finishes here very quickly, very few seconds, just finishes this up. And if I jump into Microsoft SQL over here, remember how my schemas were empty? If I right click and refresh this, now my schemas have those schema components inside of here. So there's the PAL schema, accounts, CMS, core, and CSL. It's added them to the list. And if I go into my tables and I refresh the tables, I've now got a full-on list of tables inside of here. So SQL Server now has all that same data. Now these tables are empty, but they exist, right? So if I go to something like my users table right now, and I'm targeting the webinar database, and I refresh this, there's nothing in there. These tables are all empty. So I'm looking for roles, I'm looking for users, user roles, groups, group members, group roles. They're all empty tables right now because I haven't populated. I just created the database. The structure now exists. You can do the exact same thing. Now, if you want to change the structure, go for it. You absolutely can. With the code, you can just modify the settings so you can change the structure however you see fit for your needs. Maybe you need fewer tables. Maybe you're only interested in accounts and cloud shared licensing, and maybe you don't care about the CMS or the PAL data. That's fine. Just don't build those tables. That's totally fine. Now, let's go through the next little step here. Let's talk about, after we've created the structure, let's actually get data. Let's get data written into that structure so we can actually use this in some meaningful way. So how do we do that? Well, like the JSON webinar that we talked about in the last session, we're basically going to use write all, in the case pointing to the SQL componentry, from the main.py file. And then once we run the write all, we're going to start querying the database and ask it to see if it actually has data being populated there. So let's get that started. We're going to be, again, only populating SQL Server, Microsoft SQL Server today, but let's get the write all uncommented here so we can begin that process of actually writing a bunch of data into the database itself. So I don't technically need create all active. I tend to leave it active just in case I add new tables to stuff. So I'm just going to hit F5 here, and this is going to begin running. Now it's going to take it a while. This is going to take a couple of minutes because it's grabbing a ton of data and writing it to the database. But let's go to the next little step here and verify that data actually is populating the database while that's running. So first off, you're going to want to use some kind of IDE or integrated development environment to interact with the database server. I've already been using them in today's discussion. For Microsoft SQL Server, you're going to be using SQL Server Management Studio, probably. There's other ones, but that's the typical one. For PostgreSQL, you're probably going to be using pgadmin4. There's other ones, again, but those are the two most popular, so make sure you get those if after you've installed the server system itself. Now, we're going to run some simple scripts to verify that data is actually being populated in the system. First off, let's do something simple like select everything from accounts.users and see what shows up here. So if I go to SQL Server, I've already got this one, select everything from accounts.users. If I hit F5 here to refresh this, before it was empty. Now it's populating with information. There's all kinds of data being written into this database right now as we speak. If I hit F5 again, it's actually done with this one. So it's actually already complete with getting all the users, and this is now structured data that we can use in a number of different ways. Another example might be something like select all from cloud shared licensing .app sessions. See what that looks like. If I jump back into SQL Server here, I've actually already got that script written as well. There's a bunch of them here, and if I hit F5, it's beginning to write data there as well. Actually, that's already done too. Goodness, that was fast. Let me see, do I have my content collection here? Probably this guy? Nope. Where's it at? This first one? There we go. 43,543 rows. Oops, wrong database. That might be why it was already done, because I was looking at the wrong database. 0 rows. Okay, so it is actually still back here writing this. If I target the correct database, 10,038. Nope, it is actually already almost done. PAL data, 0 rows. All right. So I'm just basically running a query, a whole series of queries that are a whole bunch of different select statements. In Microsoft SQL Server, this is convenient because I can run them all from one page, and it'll create individual queries out here one by one. Let me go back to the content here and just see if it's writing. Yep, so it's beginning to write the content now. 3,800 rows in this system already. 5,000 rows in this system already. 5,500, right? So it's actually writing the content management system data right now as we speak, 6,500 rows of data. It's going to get up to about 16,000 rows of data, and that's about how much data that I have in my database for across all of these tables with what I'm telling it to actually fetch right now. So it's going after content, it's getting all the deeper content data like content files and revisions if I was asking for that, content libraries, tags, the association of tags, all of this data, searches, save searches. It's going after that data and very quickly fetching thousands of rows of information and storing it in a structured environment. All right. Now with this, you go, Sean, why do I care? Like I had JSON files before, but like, why do I care about this? Well, let's go take a look at something over here. If I go to, did I delete that one? I must have deleted that one. Let's write a simple query here and ask it for some information. For example, let's ask it for, I don't know, all of the users that are active in the company right now. So if I said select all from accounts.users, make sure I'm targeting the correct database here, webinar database. Select everything from accounts.users. If I just hit F5, it gives me 65 rows of data. Well, if I want to ask a question like only give me stuff where the field of status equals something like active, I can ask it for that information, and it'll come back with just the 24 rows of users in my firm that are actually marked as active. This is one way to interact with the data, but it also relates to other things. I could say, well, select all the users from accounts.users, but also I want to join other kinds of information and join in what roles this user might have. Accounts.roles. Give me the roles, and actually I need to specifically go through the relational table here of user roles. I'm going to quickly alias this as UR just to save myself a whole bunch of typing, and alias this as U as a user. And I'm going to join these tables on the U.ID equaling UR dot user ID. With this, it should capital U. It should allow me to get, what the individual role values are for the user, but I want really like a display name of what those roles are. So I'm going to join again. I'm going to join in the roles table itself as R, because I like to not type as much, on r.id equaling the user roles table dot role ID. And now up here, I can actually start to do something like only give me the user display name, and also along with that, give me the role dot name, display name for the actual role. That's it. That's all I want. And show me what those pairings are, except for I typed something wrong. Oh, I didn't put on over here. That's silly me on that. All right, so if I run this now, it's going to show me all of the usernames and all of their like named out roles. I could filter this list. I could say only show me the users who are org admins in this list, right? You can start asking it deeper questions. You go, yeah, but Sean, I don't want to write this stuff out every time. I don't either. And this is why I associate Microsoft Power BI to this, and I can leverage Power BI to actually ask this data, this structured data, some extra information in a more interesting graphical chart, just like we did with Excel. But now this data here, this is stored and fetches new information whenever I tell it to fetch new information. So if I ask for new data once a week, the old data stays and new data is added on top of that. That's where this becomes much more powerful. It's no longer just an Excel file that replaces all of its data. This specifically is additive. And because it's a database, it's not just an Excel file, I can now begin to ask this database questions from other databases. And I can start to find out with other databases, users say they're doing such and such, say in something like Deltek Vision, right? That's a database of project information and time logging. Well, I can marry that up with data that's coming out of the CTC accounts system. If maybe I have a bunch of PAL data, project activity logged data, I can see where users are actually spending their time in which project models and how many items they're actually editing in there. So I can use this for some level of cross-validation much more easily when it's database talking to database, rather than an Excel file that doesn't have any real history beyond like 30 days, okay? And let's see here. So let's quickly jump into the final couple of slides here, and then I'm going to jump into the QA session here real quick. So far in this series, we've covered all the items in gray. Today, we just covered this part 3, using Python to store data in SQL. In our next session that's coming up, we're going to talk about updating information in SQL so you can refresh it, and we're going to talk about automatically scheduling that refresh so I don't have to interact with it when I want to see the data. It'll maybe refresh the night before or the hour before and have the data ready to go when I want to ask it questions. And we'll also, hopefully, in that session, take a look at tying Microsoft Power BI into looking at this SQL database. So for those of you watching this on the recording, thank you all. We hope you enjoyed this. We hope we earn your YouTube subscription on this.